Okay, over here to the right, this red graph is the graph of big F, the square root of 5x squared plus 1. By the way, when you post a problem like this, you should really put the 5x squared plus 1 in parentheses. Otherwise, we don't know if the 1 is under the square root symbol or not. But anyway, there's proof that 4, 9 is on the graph. If you picture putting in 4 in for x, 4 squared is 16. 16 times 5 is 80. 80 plus 1 is 81. The square root of 81 is 9. Now, how do you find the equation of that black line, the tangent line to the curve at the point 4, 9? Well, the first derivative will give us a formula for slopes of tangent lines to the original function. So here we employ the power rule followed by the chain rule. Of course, rewriting this as 5x squared plus 1, the quantity to the 1/2 power. So the power rule says we kind of move that 1/2 down front, reduce the exponent by 1. So 1/2 minus 1 becomes negative 1/2. And the chain rule follows by taking the derivative of the inside. And the derivative of 5x squared is 10x. The derivative of plus 1 is 0. So there is the definition of f prime, big F prime or little f. We could simplify this by taking just 2 into the 5, or into the 10, getting 5. That's what's in the numerator. And move this 5x squared plus 1 to the minus 1/2 to the denominator, using the square root symbol instead. And when I put 4 in for x in either of these, I get 20 over 9. That's the slope of that tangent line, 20/9. Now, how do you write the equation of the tangent line? Well, you could start by using point slope. There's the slope, y minus y sub 1. This is the y coordinate of the point that you know about. And this is x sub 1, x minus x sub 1. So y minus 9 equals 20 minus 9 times the quantity x minus 4. That's point slope. We could write it in several different ways. Here on this line, I multiplied every term by 9 at 9y minus 81. And if I multiply this side by 9, the 9's cancel out. I distribute the 20. If I want to, I can solve for y and have slope-intercept form. There's the slope, there's the y-intercept. Or I can put it in standard form, getting terms with x and y on one side and the constants on the other. Okay, the question didn't give directions as to what form to write it in. This is probably a good one to go to, but there's nothing wrong with point slope. There you go. Hope that helped. And if you have any questions, post a comment.